Good afternoon, ladies and gentlemen. Thank you for the invitation, although it's very short notice. This presentation has been put together in rather a hurry using some overheads, etc. I've been able to at hand. Some of these, this is part of a training program, and I've also put other stuff in. So these people have been involved in the FACET project along with lots of others, some who are in the audience. So FACET is a Flavours, Additives, Food Contact Exposure tool. It was started by a DG research project, ended in 2012. The packaging supply chain and the European food industry have been funding further developments. And one of these developments is a module to assess exposure to NIAS. We still call it NIAS, I guess by this time next year we're talking about ARPIs. Maybe the winged creatures, I don't know. So what does NIAS contain? It contains databases, an extended harmonized food consumption database for regional modelling. This is the same database that EFSA uses. The database on the occurrence and concentration of substances in food contact materials or their components. Industry supplied this data on the condition that it was proprietary, it was their trade secret, it was their lifeblood. And so it is, unfortunately, people cannot access it. And we use packaging usage statistics for most of the EU member states from a company called Euromonitor, which I believe a lot of companies in this room may use. In the model, we've got two tools. We've got a migration model for multi-layer and multi-materials, as well as paper and board. And we've got a software exposure tool, which is stochastic. So you will get a distribution. So every time you run it, you'll get a slightly different number. Only very slightly, but you will never get the same number every time. So what can it do? It can estimate exposure to existing substances in food contact materials at varying levels of detail. And it can, for example, if a member state runs a surveillance survey and finds levels of a substance in the food, you can do an immediate exposure assessment of that substance. What you then do with it depends on the toxicology. We can estimate exposure to substances coming from new packaging or coming from new or existing substances. And lastly, we can estimate exposure to new substances in NIAS. NIAS is really an extension of the new substance functionality. NIAS is just like a new substance. If you want to estimate the exposure to a new substance, you would put the necessary parameters in and you would get exposure. So if you do the same for a NIAS, you can get an exposure. And we'll see there is an area, and we'll talk about this later, where if you don't know the molecular weight on the log POW, then you may need to put in a concentration, and we'll see how that can be done. Unfortunately, I didn't have time to do that for this presentation, but there will be a publication sometime next year. So the concentration of the substance in the foodstuff is either by migration modelling or by concentrations or migrations. And having obtained the concentration, it's necessary to calculate how much person consumes per day of that foodstuff using dietary surveys. So really this builds on Benoit's presentation this morning, and this is how we're going to get the exposure for the MOE experiments. The most common reason for doing it is you can compare the toxicology of the substance and make a judgment on its impact of its safety. Basically, a margin of exposure. To get the exposure, we need to know what is its concentration in the food and how much of the food every person in the population in the survey ate. And most of these surveys are around 2,000 people. We've got two routes for getting concentration. There is the migration model from Farbes and Fraunhofer, used for plastics, paper and board and inks. And we have extraction data for can coatings, for metal lids, etc. These are the countries for which we have dietary surveys. I'm pushing a little bit quickly because we're short of time. How do we know that FACET works? It's a black box. So we actually used FACET to estimate exposure to BPA. I mean, everyone's mentioned BPA, so why not me? The methodology, along with its inputs and results, have been published, and it's in this peer-reviewed, and it went through a lot of peer review, I assure you. So if we actually submitted our exposure estimate before the EFSA opinion was published. And we compared our estimate with scenario 2 of the EFSA opinion, exposure opinion, and the conclusion, the conclusion is that it was a conservative scenario that EFSA used, and we've got very, very good agreement. I couldn't cheat better. I really couldn't. And to my mind, this demonstrates that using the tool does actually give us a realistic answer. And all of the input parameters are available in the paper that was in this paper. If you go there, it will tell you all of the inputs, the packaging usage, etc. And it also contains a refined deterministic approach as well to compare it against. So we believe, or I believe anyway, that this is a demonstration that you can get a realistic exposure estimate using FACET. Now, the question is NIAS. What do we do with it? Well, we can calculate the exposure to NIAS from a metal and non-metals. It can be as an impurity. NIAS is various things. Or it can be in a material. If you measure a NIAS in a material, it may not be related to a starting substance. It could be a reaction product. If it's an impurity, you generally know what it is. And you can also do an exposure calculation for NIAS or impurities in crisis situations. Do you really have a health issue? Do you have a safety issue? It gives you a tool for an informed decision. Having got an exposure assessment, you can then use that along with toxicological data, TTC, other approaches to determine whether you have a risk. This FACET is one part of a risk assessment. It is not the answer to a risk assessment. You need FACET, you need toxicological information. So, let's look at tributylaconite. It's NIAS present in ATBC at 7%. ATBC is used in inks and what is the exposure? We've taken the UK 19 to 64-year-olds. What are the risks? We know its molecular weight. We can calculate its log POW. Why can't we just say, well, it's 7% of ATBC, therefore it should be 7% of the exposure to ATBC? We'll see in a moment. Well, the molecular weights are different and the log POWs are different. And if you look, and the two of us, as I've said already today, two people running it will get slightly different numbers. So we ran the exposure assessment and we found that the 7% impurity resulted in 8 to 8.5% higher exposure than you would have got from ATBC. So you cannot say it's 7%, therefore 7% of the exposure will be attributed to this. You could, as a rough measure, if you didn't have a toxicological concern. And why is there a difference? Different log POW, different molecular weight. So what is the actual exposure? We have the mean exposure and the 95th percentile exposure. We look at the 95th as representative of the high consumer. And we concluded the mean was 0.128 micrograms per person per day, and the 95th was 0.421. It included consumer loyalty and set-off. So we found that the biggest group for the exposure was bread and bakery wares, the flexible wrappers, and the plastic top. I've got a pointer. Yeah. This is the total exposure, and this is the exposure per pack type. Each of the pack, there are 102 pack types in the database, and these consist of different layers being put together. And this is by far the biggest driver. And if we go back one, and this way you can find out which foodstuff is driving it, and you can do this either way. So there's no tox data on tributyl aconitate. So what do? Well, based on the fact that ATBC forms tributyl aconitate in solvent solutions, it's reasonable to assume, I'm not a toxicologist, and I say this, so please don't ask me toxicological questions, that ATBC and tributyl aconitate have similar toxicology, 1 milligram per kilo body weight per day. Therefore, if we have a microgram or less per kilo body weight, we can say it's an acceptable risk in the adult population. Now let's look at another question. We've already said that a new substance and NIAS, the approaches are very similar. So let's take a new substance now. I'm developing a new product, and it's a new plasticizer that gives really good adhesion in polyester films. And I'm using it at 5% in a dry ink film of 70% of all nitrocellulose inks. Both Gravure and Flexo for polyester. What would be the exposure for the French population? And in this case, I've got a toxicological limit of 0.01 milligrams per kilo body weight. The parameters we know because it's a substance we're deliberately adding. We get the mean exposures, and we get 11.2 micrograms per kilo 95th, and 3.7, or another user got 14.6 and 2.7. This would be typical variation. If you're very close to that limit, then I think we'll have issues. The toxicologically acceptable limit is 10 micrograms per kilo body weight. Therefore, there could be an unacceptable risk. And what is driving this risk? Well, we can look at FACET, and again it will show us that it's flexible bags, wrapper, pouch, and cereals. So here we have the main contributor to the exposure. And again, it just so happens in this case, it's the flexible wrappers, bags, etc. Which is not surprising when you consider the types of foodstuff we're talking about. So, So we've shown that FACET can be used to estimate exposure as part of a risk assessment for NIAS substances, and in conjunction with toxicological data, approaches can be used. We can assess the safety of a food contact material. We can use FACET to estimate exposure as part of a screening test for introducing a new substance or a new package onto the market. And we can estimate exposure to any food contact material substance for which concern arises. We can give you part of the puzzle. We cannot give you the complete answer. All we can say is, this is the exposure. Along with the toxicological profile, does it give you cause for concern? And thank you very much for your attention. The website is here if you want to find out more from the JRC.
Thank you very much, Mr. Oldring. And we have now we have some time for some questions. There's Jane and then somebody